Welcome to the Sonic Sciences Psychological Series. Today it's all about time. Have you ever wondered why, as a kid, summers seem to stretch on forever, but as an adult, years zip by like the pages of a book flipping in the wind? Well, you're not alone. And there's actually some science behind this feeling. Let's discuss why the years feel shorter and shorter the older we get. First, let's talk about a concept known as the proportional theory. Imagine you're only 2 years old. 1 year is half of your entire life, which is a massive chunk of your personal experience. Now, when you're 70, 1 year is just over 1% of your life. That math holds true to days, hours, and minutes as well. This drastic difference in proportion gives younger people a feeling that time is expansive and slow. But it's not just about feeling, it's about perception. Our brain encodes new experiences more thoroughly than routine ones. As children, almost every experience is new and filled with detailed memories. And forming these memories takes time and makes time feel longer. As adults, we fall into routines, and fewer new memories are formed, which makes time seem to go faster. Interestingly, this perception influences our patience and urgency as we age. When you're young, waiting for your birthday can feel like an eternity. But as an adult, a year can pass in a flash, and with it, deadlines and commitments seem to pile up more quickly. This can make us feel constantly behind or in a rush, as if time is slipping through our fingers. To sum it up, the days are long, but the years are short. This isn't just a poetic reflection, but a psychological reality shaped by the changing ratio of new time to total time as we age. So, next time you feel like time is flying by, remember it's a part of growing older, and maybe, just maybe, it's a sign to start looking for new experiences to enrich our days and stretch out the years. And remember, the beauty of time is that it's both a gift and a mystery, one that we can understand a bit better with a dash of science. Thanks for tuning in, and don't forget to cherish each moment because time, indeed, waits for no one. It's about time to like, comment, and subscribe to Sonic Sciences, a few clicks, and then back to the program. That's the energy exchange. And clicking is a lot less time-consuming than make these presentations. So give back some energy by clicking the button, you know the one. All right, now let's take this a step further. Have you ever heard of time dilation? It's a concept from Einstein's theory of relativity. According to this theory, time can actually slow down or speed up depending on how fast you're moving relative to something else. For example, if you were traveling on a high-speed train, time would pass slightly slower for you compared to someone standing still. Astronauts on the International Space Station experience time a bit differently than we do on Earth because they're moving at high speeds. There's also gravitational time dilation, where time moves slower in stronger gravitational fields. Near a black hole, time could almost come to a standstill. Now, let's consider the quantum realm. Quantum mechanics introduces even more mind-bending concepts about time. At the quantum level, particles can exist in multiple states at once, and their behavior can be influenced by observation. Quantum entanglement suggests that particles can be instantaneously connected, no matter the distance between them, hinting at a deeper connection in the fabric of time and space. Some interpretations of quantum mechanics, like the many worlds interpretation, propose that every possible outcome of a quantum event actually occurs, creating a vast number of parallel timelines. These ideas even open the door to the possibility of time loops and time travel paradoxes, where the past and future could be intertwined in complex ways. But despite these mind-bending theories, one thing remains constant: the arrow of time. This concept, rooted in the second law of thermodynamics, states that time moves in one direction, from order to disorder, or from low entropy to high entropy. This increase in entropy gives us the perception of time moving forward, creating the past, present, and future as distinct entities. In the grand scheme of things, time is often considered the fourth dimension, intricately woven into the fabric of the universe alongside the three spatial dimensions. Imagine time as a river flowing through the landscape of existence, carrying us along its currents from one moment to the next. Or think of it as a tapestry, weaving together the moments of our lives into a rich and intricate pattern. Some cultures even view time as a spiral, with cycles of growth, decay, and renewal repeating over and over. Ultimately, time is a journey, taking us through different stages of life, each with its own unique experiences and challenges. One way to make the most of this journey is to practice mindfulness, living fully in the present moment and appreciating the here and now. By cultivating gratitude for the moments we have, we can enrich our experience of time and create lasting memories. Remember, time is a precious gift, and its mystery is part of what makes life so fascinating. Thanks for tuning in, and don't forget to cherish each moment because time indeed waits for no one. Well, now it's about time to like, comment, and subscribe to Sonic Sciences. Thanks again. Take a brief time out to go get some refreshments before we go even deeper into the time-space continuum. Now, to consider Einstein's theories on time and how they revolutionized our understanding of the universe. Albert Einstein, with his groundbreaking work in the early 20th century, introduced us to concepts that forever changed how we perceive time and space. First, let's try to understand the idea of space-time. According to Einstein's theory of relativity, time and space are not separate entities, but are intertwined into a single continuum known as space-time. This concept suggests that the fabric of the universe is a four-dimensional tapestry, where the three dimensions of space and the dimension of time are woven together. One of the most mind-blowing aspects of Einstein's theory is time dilation. This phenomenon occurs when an object moves at speeds close to the speed of light, or is in a strong gravitational field. Time dilation means that time actually slows down for that object, compared to someone who is stationary or in a weaker gravitational field. Imagine you're traveling in a spaceship at near light speed. While only a few years might pass for you, decades could pass on Earth. This isn't just science fiction, it's a proven scientific reality. Astronauts on the International Space Station experience a tiny bit of time dilation due to their high-speed orbit around Earth. Over the course of their missions, they age slightly less than people on the ground. But time dilation isn't limited to speed. Gravitational time dilation occurs when time slows down in stronger gravitational fields. Near a massive object like a black hole, the gravitational pull is so intense that time almost comes to a standstill. This mind-bending reality shows how interconnected and relative our perception of time truly is. Einstein's theories don't just stop at time dilation. They also introduce the concept of the curvature of space-time. Massive objects like stars and planets warp the fabric of space-time around them, creating what we perceive as gravity. This curvature affects not only the path of objects in space, but also the flow of time itself. As we ponder these revolutionary ideas, it's clear that our understanding of time is far more complex and nuanced than we might have imagined. The interplay between space-time, gravity, and motion reveals a universe that is dynamic and interconnected, where time is not a constant but a variable influenced by the cosmos. To conclude, Einstein's theories have deepened our appreciation for the mysteries of time and space. They remind us that our perception of time is just one piece of a much larger puzzle, one that continues to captivate scientists and thinkers alike. So, as we navigate our daily lives, let's remember that time is not just a ticking clock, but a profound and intricate aspect of the universe. By exploring these concepts, we can gain a deeper understanding of our place in the cosmos and the true nature of time itself. Thanks for tuning in and spending some time with Sonic Sciences. I am formally inviting you to like, comment, and subscribe, and become an active part of Sonic Sciences. Until next time, time out.